basically we don't have the scaling available. And so there are unresolved problems with fluorine-free foams. There is an issue about scaling. There's a issue about fuel pickup. So when the foam hits the fuel, the fluorine-free foams may have bigger fuel pickup. There is a performance issue about high temperature. So I just want to tell you that all those testing was usually done in Northern Hemisphere, and it designed for Northern Hemisphere fires. It wasn't designed for hot environment that we have in Australia or in Indonesia. And so really, people need to take a closer look into performance of the foams at high temperature. What matters is the temperature of the air, not the temperature of the fuel. I have to accelerate because I guess I'm getting over time, but this gives you the composition pathways for the foam this typical fluorosurfactant in the environment. The head groups may be oxidized, and then the results of this oxidize further and to produce carboxylic acid. Form meaning that you have C2H4 link, the preferred contaminant in the environment is whole range of carboxylic acids. Here's again the decomposition of the fluorosurfactants in the environment. They are basically chemicals that are very resistant to biodegradation. So if you put those chemicals through a water treatment plant, they come just in the at the other end. So there is inappropriate to dispose fluorochemicals. Probably you all know that through the water treatment plants, because water treatment plants do not handle them. And so basically that just says that the fluorosurfactant that would go through the water treatment plant would just mostly go unchanged. Well, the head group would get oxidized, but the rest would go unchanged through the plant. Longer surfactants in the environment, but they are absorbed on the water, on the particles. So you start pumping water, treating them and pumping it back, and they start coming out. But they do not move in the environment as quickly as shorter surfactants. Okay, then I just want to say that there is something called precautionary principle, that if you don't know the properties of new chemicals, we should not be using them because in future we may find unfortunate effects. And then the replacement of C8 by C6 is against this precautionary principle. We're using them because they are very good, but they could be effects on people and the environment that we don't know yet. And again, I say here that modern AFFF C6 should not be disposed in water treatment plants. They need to be incinerated because there's no other way of breaking the very strong carbon-fluorine bond. So that I put some information from the literature about toxicity by accumulation of PFAS. I am not an expert on genotoxicity, mutagenicity, and so on. Professor Fatma Lestari is an expert on this. She did her PhD on this. I am an engineer and a formulator working on formulation and physical aspects of the foams, but I'm not expert on this. So I brought to you some of the considerations that on the replacement they have lower toxicity than PFOA. Uh, they effects of the new replacement of the firefighting foams uh, were milder and generally reversible. So they generally not toxic and generally not bioaccumulative. But the problem is that with the environment, they tend to spread through aquifers quicker. Uh, and again, the same uh, uh, information here. This is about toxicity of the fluorosurfactants themselves. In the environment, they would oxidize to shorter molecules. Uh, but the kind of consensus is that the C6 are less toxic than CH. And I just want to say that we'll be Ted Schaefer and myself and others in 2002, we published a paper in which we say that's where 3M future the use of fluorinated surfactants will be substantially regulated for all but a small number of critical applications. As a consequence of their highly dispersive use, it is likely that fluorinated surfactants included in firefighting foam formulation will be scrutinized, and that future is now. In Australia, we obviously federal state, and so every state would have a different regulation. But in South Australia, we are not allowed to use C6 foams, period. The same is true for the state of Queensland. For the state of New South Wales, which is the most populous state in Australia, the approach is slightly different. The New South Wales allows to use C6 forms. But if you have a fire that you cannot control with fluorine-free foams, then you're allowed to use C6. Also, you're allowed to take C6 extinguishers on your boats. But again, you're not allowed to discharge them tightly control in my country and probably around the world. And then just word of caution, compatibility. In a sense, Indonesia is very similar to Australia. A lot of people live around the coastline, and our fire safety system on the ships. And so it's important to realize that compatibility of foam formulation with seawater is very important. And so when you shop for a foam that is compatible with seawater, then you really have to check what standard was used to test the seawater. Because what people do, they make synthetic seawater and then they test for compatibility. The best test, the best synthetic seawater is this one made according to ASTM D1141. That formulation contains all the major metals and major anions. It contains bicarbonate, it contains borate, and most importantly, it specifies pH. pH of seawater is 8.2. And if you don't specify pH and you don't have all the cations and anions, you're not really testing with true seawater. And so the test for compatibility with seawater done according to UL 162 and mil-spec use ASTM 1141. And this is the good stuff. If you have compatibility with seawater, you know that this foam would perform if used with seawater. Many other standards basically only use hardness. They would add calcium or magnesium and do not add other elements. And they call it compatibility with the seawater. And that's really not correct. Fall short about sodium chloride, 10 grams of magnesium sulfate dissolved in one water and 1 liter. And this is it. It is not really seawater. The pH is not controlled here. It doesn't have boron. It doesn't have bicarbonate. Doesn't have calcium. And so UK military standard and European standard slightly better, but yet not perfect because it doesn't have pH. So I just want to sensitize you that when you're buying the foams, look at the standards that that foam was tested against, and also check the compatibility of seawater if you happen to be on the coast. And so this is one of the examples that we pick up from the literature.
Professor
That I'm
excuse
finishing.
me. Okay.
1 minute. 1 minute.
Yes.
Is it okay? 1 minute.
Please. Yes.
Thank you very much. Well, I have only two more slides to go. And so the take-home messages are there is now intense competition between modern AFFF and fluorine-free foams. Modern AFFF and fluorine-free foams satisfy all the standards except mil-spec, military standards. One must select foams that have the best performance on the performance standards. That usually means UL 162, ICAO protocol in that order, US UL 162 ICAO, and then probably this EN standard. Modern AFFF still decompose into perfluorocarboxylic acid. They are less toxic and not bioaccumulative than the previous forms. So there is the health is certainly better taken care of. Don't know all the effects of the forms, so one should be careful in the treatment plants because they are not being treated in those plants. And don't believe everything that you read in trade literature. Ask for certificates of actual testing protocols and results. Demand release of all data. Do not accept performance comparison between FFF and legacy, between F3 and legacy AFFF. Accept the latest data, the latest performance. The performance narrowed, and if you look at the literature that's 2 years old, there still was divergence. So I think that's quite an important point, and I almost done. And just would like to acknowledge people who are important to myself in improving my my expertise in the field. I work with Ted Sheffer, my initial PhD students from University of Newcastle, Bruce Gardiner, Amir Maghrabi, and then several people from either industry or the testing organization that I work with. On that note, thank you very much, and apologies of going over time, and thank you very much, Fatna, for stopping me.
Thank you very much, Professor Boccio, for your very interesting, and this is a very
Hello, Professor. Hello, Professor Fatma. I think there might be problem with the signal or something.
I think so, Kamaranda.
Okay. Yeah. So Professor Bogdan, maybe I just will help Prof. Fatma to continue first, and after she come back, she will continue to moderate the Q&A discussion. So first of all, we have some question here, and I will just get through the question. And because of some, okay, so first, I will have, we have question from Irfan. Can this kind of foam extinguish the bioethanol gasoline with ethanol? I'm not really sure what this.
Well, I think that there are problems with extinguishing those fires experienced by all foams.
Okay.
I think that whether it is fluorine-free or AFFF, there are issues with extinguishing fires of polar liquids, and so I would like to
Sorry,
say
my
that
apologies.
perhaps successful extinguishment of ethanol fires with fluorine-free foams. I think that first of all, on those fires, you need to use, as you probably know, the alcohol-resistant formulation or alcohol-tolerant formulation that contains biopolymers. But the experience that we have in Australia is not very good. We have a large fires, I think, in Wollongong about a decade ago, and we couldn't extinguish it with fluorine free forms, and so one has to be very careful, and polar liquids. But if I were to advise, I think that in that situation, my preference would be to go with C6.
As Prof. Fatma is already here, so I just help the question number 1, Prof. Fatma, from the Q&A section from Irfan. So Professor Bogdan just answered the question from Irfan, and please continue. Maybe we can get through another question, maybe from panelists or another attendance for live question. Thank you.
Okay, sorry, my apologies. My signal is suddenly drop out. Okay, I would like to invite my best colleagues from Department of Occupational Health and Safety to deliver the questions, especially probably first for Professor Meili, Prof. Meili, or maybe Bapak Dr. Insinyur Syahrul. Any questions? Or
thank you.
Pak Dadan? Yeah, Bu Bian?
Listener.
Oh, okay, Bu. Prof. Meli, just listen ya. Okay, Pak Syahrul, Bu Bian, Pak Dadan, Pak Hendra, Mas Mufti. Apakah, is there any question for Professor Brodsio? Pak Hendra? Oke, baik. Mungkin untuk saat ini belum ada. So, we'd like to move to the questions from the attendee. The second questions, I would like to invite Mr. Paul Wijaya to send the questions directly. Pak Paul Wijaya, are you available at the moment to speak out?
Yes. Can you hear me, Professor Fatma?
Yes.
Yes,
sure.
No problem.
Good.
Okay, thank you very much for the opportunity. I've got 3 questions I raise. First of all, I read from last fire report that testing has not been done so far for large storage tank, means that more than 40 meters in diameter. Has it been progress so far?
No, you're right. I think you're very true. That's very true. That we have no progress in that field. In other words, we don't know how those foams perform against very large fires. I guess someone has to put tens of thousands of dollars to allow those testing to take place. And people ask very reasonable questions about scaling. We know that 3M and Zollberg have provided some scaling on relatively small fires, like up to 40 meters. We know that we have to increase application rates higher. So it's not scaling linearly as F6, so C6 would do or 6.8 would do, but we don't have no data. So as far as I know, no progress.
Okay, can I ask one more question, Professor Ratna? I think
yes, sure.
The other one has been explained by Professor Gorski. Sorry to pronounce your name. The other one is, do we need to change some of the equipment if we want to switch to F3 foam?
Yeah, yes, absolutely. You again correct on this one. There are two issues. The one is issue of the size of the storage tank for concentrate, and the other issue is the proportioners. So the fluorine-free foams that were developed until until probably 2 years ago, they all characterized by very high viscosity, and they also characterize what is called non-Newtonian behavior. And so the foams would shear thin, and you pump them, and the viscosity goes down. But to start pumping them is difficult because they have yield stress and so on. So you need to have bigger tanks for those foams. You need to have bigger pumps to start the flow, and then you have to have proportionals that have been tested to mix that high viscosity concentrate with water. So those are the. So I didn't speak about this. I spoke about this only about the performance, but there are a set of problems on the equipment size. Now those three problems about bigger facilities are required. The pumps should be bigger, and the proportional should be checked. But however, I would like to say that there are manufacturers that are coming. At least I know one formulation that is Newtonian and is low viscosity, probably two. So this is changing situation too. So I guess depending of the form that you specify, then you have to look at viscosity, whether it is shear finning or not shear finning, and then you design your system accordingly. And I just want to stress that your question is spot on. It is a problem that people should be aware that it's not just a drop-in replacement. There needs to be changes in the installations too.
Okay, thank you very much. Thank you, Professor Fatma.
Thank you very much, Mr. Paul Wijaya. I think we're gonna move to the second question to Bapak Nugrahanto Widakdo. Please speak up and deliver your questions. Are you available? Are you available to speak, Bapak Nugrahanto? Okay, probably not available at the moment. Okay, I will move to the next question, Bapak Bambang Hirawan. Yeah, it's about the Balongan refinery. Yes, we just having a large fire oil tanks, as I mentioned, Professor Boccio recently. So I think Pak Bambang Hirawan would like to ask you about this one. Pak Bambang, monggo silakan. Are you available to talk? But probably Mr. Bambang not available at the moment, but I would like to ask and deliver Pak Bambang Hirawan question, Professor Boccio, how to manage firefighting in tank fire. So recently we have a tank fire, large tank fire in the Balongan refinery, and the foam is not working very well. And what is your suggestion on how to design applicable foam like PFSA PFAS in the tank premium to the following standard. Please.
So do you know whether the foam that wasn't working was fluorine-free, and whether it was bought or tested to a standard before purchasing? So if the foam is, like C6 should perform, right? If there's a good C6 formulation that meets UL 162, and that there was no changes in the formulation when sold, that C6 should perform. The good fluorine-free foam, say from Zollberg or from Angus and from Ansul, that have tested fluorine-free to high standards, should also work. So I'm not familiar with the situation, but one possibility would be that the foam perhaps the formulation was incorrect or not correct. The selection of the foam and selection and checking the standards, and that it has standard, asking for certificates, and perhaps retesting it yourself, is important. But in principle, if the second thing is perhaps the application rate is important. So I'm not familiar with the local situation, so I'm just guessing what could have gone wrong in terms of the form or the application rate.
Yep. Okay, I will note it, your comment about this, but yes, we do have problems. I think it took several days to extinguish the large oil tanks during the Balongan refinery fires. So this is a challenge for us. Yeah.
How big was the fire?
It's about 4 tanks, oil tanks.
And how big are the tanks? Like in the diameter?
The diameter, I guess, more than 50,000, right? I guess. I don't know. Bapak Bambang Hirawan? Yep. Just a normal or depot.
Yeah. Like if the fires are bigger than 40 meters in diameter, there is, we don't know. I mean, if the fires are too big, then there is no successful extinguishment, as far as I know, using fluorine-free foam. So it may be also one of those cases that the tanks were the fire was too big. And if the fluorine-free foam was used on those tanks, we now know that it's not easy to extinguish with large tank fires with fluorine-free foam.
Oh, okay. Yeah, maybe the fire. I'll show you the condition of the Balongan oil refinery. So can you see my screen?
Yeah, I can see it.
Yeah, so this is during the extinguishment.
Yeah, the tank is collapsing. Yeah.
Right. I think there are 4 big. There are 4 big. If you can see the oil tanks fire. So this is the 4 large fires has been burned. Yep.
Yeah. They could be outside the conditions of what we know that the foam would work. Probably there's a radiation feedback between the tanks that makes the extinguishment more difficult. Yeah.
All right. Okay. Okay, thank you very much for your advice. So I think we would like to move to another questions. It's come up here from Bapak Adi Mulawarman. Bapak Adi Mulawarman, are you able to speak up?
Yes, Professor Fatma, thank you.
Yeah, thank you, Pak. Monggo, silakan.
Professor Gorski, as I know, for fire suppression system standard, that the standard will test and certify not only the material, but also the equipment and piping system used. My question is, mil spec UL and ICAO standard for foam system will test and certify the equipment and piping system too, or only the foam material? Thank you.
Or depends on what standard you're using. So there are distinctions between performance standards and design standards. So if you're using just performance standard, I would only test the foam, the performance of the foam, and then you have to use design standard to design the equipment. I think NFPA 16 would do both. But I don't think the most standards that I covered today were performance standards. So while there are standards that cover both, usually they are separate. So ICAO is also the same. So ICAO includes both performance and design standard in the one document. But from what I understand, usually that's separate. So you check performance, in one standard, you apply the safety factor, and then you use design standard to design the equipment.
Okay, thank you, Professor Gorski.
Thank you.
Yeah, thank you very much, Pak Adi. Pak Adi is from SKK Migas, right?
Yes, Prof.
So he's the regulator for oil and gas upstream, Professor Botsio. So I think this is a very important question. And the next question, I would like to invite Bapak UU Supardi to deliver the questions. Are you available to give the questions? Oh, I think he's not available at the moment. So I will move to the next attendees, Bapak Budiman Mazrun. Bapak Budiman, ya silakan Pak Budiman. Professor Botsio, you can drink first.
Oh, no, I'm good.
Okay.
I'm good. Thank you very much.
Yeah, but we are here not permitted to drink because yeah, at the moment fasting.
Yes,
Ramadan.
I understand. You're in the middle of Ramadan, yes.
Ya, ya. Jangan lupa ya Bapak Ibu jangan ikut minum. Okay, then the next attendee question is Pak U. I think Pak U is available. Pak UU Supardi, are you available? No? Okay. Pak UU, apakah sudah bisa bertanya? Okay, I think he's not available. What about Bapak Jumri Nur? Bapak Jumri Nur, are you available to deliver your question? Bapak Jumri? Enggak juga ya. Pak, yang lain? Satu lagi. Oh, Bapak Jumri. Bapak Jumri, apakah bisa bertanya? Menyampaikan langsung pertanyaannya?
I think
Pak Jumri not available. Maybe a problem your connection. And I think I move to Bapak Nugrahanto Widakdo. His question is about, does any of fluorine-based foams also create a side product during firefighting, such as toxic hydrofluorine? Hydrofluoric acid gas.
Well, we not tested directly. So I don't have data at the fingertips, but there is possibility for HF being formed. Because of high temperature, and it is possible that HF is formed, but I haven't. So I'm not familiar with literature that flagged this as an important problem for firefighting with foams, as opposed to firefighting with clean agent like FM200, where the gases suppressants are containing fluorine. the concentration of HF could easily be thousands of ppm in the air, and it's quite toxic. And people have been killed by fumes coming from suppression of fires with fluorine, clean agents. So while I'm not familiar with the data on HF formation using firefighting foams, I would not expect that to be a major issue. There's possibility always, but since I'm not familiar, it will indicate that there's probably not an issue with firefighting foams. The formation of HF in the gas phase, yeah.
Okay, thank you very much for your information. So I would like to move back to our panelists, my best colleagues from Occupational Health and Safety. Is there any question from our colleagues? Maybe Mas Stefan, Mas Adi, Pak Hendra, Mas Mufti, Mbak Miranda, Bu Bian. I'm calling for questions. All right. I guess there's no more questions. So we can close this session with you, Professor Bozzio. Thank you very much for your wonderful presentation, and also very important as we are facing this problem with firefighting foams. And I would like to inform you that this international guest lecture is made available based on supporting funds, fellowship, and also the grants, international grants for achieving international accreditation and academic reputation improvement. Thank you very much for today's session and valuable information that you presented. I think this is very important for Indonesia and also for OHS experts. Thank you very much again. I forward this to Miranda.
Okay, thank you, Prof. Fatma, and as well as Prof. Bogdan for a great discussion session. And so this is the end of the international guest lecture today. So we would like to thank our speaker of the day, Professor Bogdan Dugogorski, for a fruitful discussion, and also our moderator, Professor Fatma Lestari, as well as all the parties that contribute to today's event. So we also like to thank you for your participation in this online seminar. We do apologize for any inconvenience in today's event. And as a reminder, all participants are expected to fill in the attendance on the link that we have sent to the chat column. And e-certificate will be sent to each participant in accordance with the data during the registration. And so before I close, I would like to invite our panelists to take picture together. So our panelists, please activate your video so we can take picture together with Professor Bogdan. I invite once again for our panelists to be able to activate the video so we can take picture together.
Okay, I think no video, Miranda. I will.
Okay, capture, yeah.
3, 2, 1. Once more. 3, 2, 1. Okay, thank you, Miranda.
Thank you. And so this is the event today that organized by the OHS Master Program Faculty of Public Health Universitas Indonesia. Thank you so much, and I close this event. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much.
Thank you, Professor Bogdan. Thank you, Prof. Fatma.
Thank you, Prof. Fatma.
Thank you, Prof. Fatma.
Thank you, Bu Bian. Thank you very much,
Thank you.
Professor
Bye-bye.
Bozzio. Thank you very
Bye.
much, Mas Mufti. Bye-bye.